Here we are in Chapter 5, Review Exercises numbers 25 through 33. Now we are solving by factoring. And remember, the whole purpose is we can't just combine the x's together like we did back in the earlier chapters and solve the equation because they are not like terms. That is impossible. So we had to come up with a new way of solving, and that is getting it equal to 0 and factoring. Step number 1. Get everything equal to 0 and all multiplied out. So like this, number 27, we have to multiply that out before we can get it all equal to 0. And then step number 2, that is when we factor it. And remember, we have pull out the greatest common factors, method 1, grouping, trinomials that are x squared plus bx plus c, leading coefficient not equal to 1, and then we have the special cases, difference of squares, sum and difference of cubes, or perfect squares. So we have 5 different ways of possibly factoring it, and then each individual factor equals 0 will give us a solution. That's why we got it equal to 0, because when we multiply factors up to equal 0, one of them has to equal 0, and that'll give us an answer. All right, let's start with number 25. So is it equal to 0? Check. So now we're factoring. Pull out the greatest common factor, which is a 5. We're left with x squared plus 4x plus 4. Good. Oh, this is leading coefficient 1 of a trinomial. That's nice. So that's x there and an x. What times is to 4 and adds to 4? That's plus 2, plus 2. Excellent. Now we let each piece equal 0. 5 equals 0. There's no x in that. That's a dumb equation. X plus 2 equals 0 gives us x equals a negative 2. And then x plus 2 equals 0 will give this one a second time. So this guy actually happens twice as a double root or a double solution. But it's just the number 2, negative 2 is the only number that works. Alrighty, the next one, number 26. X squared plus 3x minus 40 equals 0. Is it equal to 0? Check. Step number 1 is done. Step number 2, is there a greatest common factor? No. It is a leading coefficient with, trinomial with leading coefficient 1. So we got to look to negative 40 and see what adds to a positive 3. 1 and 40, 2 and 20, 3, nope, 4 and 10, 5 and 8. And it looks like that guy right there with a positive 5 and positive 8 and a negative 5. X plus 8, x minus 5. And then, now that it's factored, step number 3, get each piece equal to 0. So x plus 8 equals 0 will give us x equals a negative 8. And x minus 5 equals 0 will give us x equals a 5. So we have 1, 2 answers. Number 27. Oh, it's a pity that it's not equal to 0 right now. We could just read off the answers. But since it is not equal to 0, we need to multiply all this out. We get a 6x squared plus 12x minus 5x plus 5x plus 10. And then we're going to add this 2 over here. That gives it equal to 0. So we have 6x squared plus 17x plus 12 equals 0. So far, so good. Now, factor it. So can we pull out a greatest common factor? No, we can't. Is it how many terms? 1, 2, 3. 3 terms. Leading coefficient is 6, so we have to take 6 times 12 is a 72. Could be a 1 and a 72, or a 2 and 36, or a 3 and a 24, 4 and an 18, 5, 6 and a 12, or a 7, 8 and a 9. What would add to 17? Looks like that 8 and that 9 will. So it's really 6x squared plus 8x plus 9x plus 12. Now chainsaw. So we get, pull out a 2x, and we're left with 3x plus 4. And then pull out, what can we pull out of that second half? Maybe a 3? Yeah. And we're left with 3x plus 4. So now pull out that 3x plus 4. And we're left with a 2x plus the 3. Oh, good. And that's equal to 0. Woo! That one took a long time to get through the factoring step. And now we're down here. Let's let each one of these equal 0. So if 2x plus 3 equals 0, let's write that up here. Then we subtract 3 from both sides and then divide by 2, and we get one of the answers. Now if we let the other one, 3x plus 4 equals 0, subtract 4 over here and we get minus 4 divided by 3, and there's our other answer. So negative 3/2 and negative 4/3 are the answers on that one. Number 28, 121y squared minus 25 equals 0. Is it equal to 0? Yes, it is. Factor it. We need to now factor 121y squared minus 25y squared. No greatest common factor there. Two terms, and it's a difference of, this is a perfect square of 5 times 5. That's a perfect square of 11 times 11. So that tells us how we're going to factor this. This is 11y and a 5, and 11y and a 5. One's a plus and one's a minus. That's a difference of squares. Now that's equal to 0, so each factor equals 0. 11y plus 5 equals 0. Subtract 5. 11y equals a negative 5. Divide by 11, you get y equals negative 5/11. Here we have 11y minus 5 equals 0. Add 5, and we get y equals, add 5, and then divide by that 11. And here are our two answers for number 28. Number 29, 2x squared minus 11x plus 12 equals 0. Is it equal to 0? Yes, indeed it is. So that means we can start off with factoring. Factor, we have greatest common factor. No, that 11 doesn't have anything to go into it. So the greatest common factor, we pull out, nothing there. 1, 2, 3 terms. Trinomial. Leading coefficient is not equal to 1, and it's not a perfect square. 2 times 12 is 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. We got to add up to a negative 11. 3 and 8 add up to 11. If they're negative times negative, that'll be a positive 24. Good. So let's split the middle. This is really a 2x squared minus 3x minus 8x plus 12. Chainsaw. Cut that guy in half. Pull out what we can from the first half. That's x. And if we pull out an x, we're left with 2x minus 3. What do we have from the second half? Maybe a minus 4? That's what it looks like. And then we're left with a 2x minus 3. So if we pull out that 2x minus 3, we're left with the x minus 4. There we go. And that all equals 0. Oh man, that took a little while to factor. Now each factor equals 0, so x minus 4 equals 0 will give us x equals 4. I love when they simplify down to these small equations where we can deal with them just a little piece at a time. And 2x minus 3 equals 0. Add 3 and divide by 2. And here are our couple of answers for number 29. All right, number 30. X squared minus 12 equals x. Is it equal to 0? It is not. We got to subtract x from both sides. Now put it in the middle so he looks nice. X squared minus x minus 12 equals 0. Good. Now we factor. There's not a greatest common factor to pull out, so we actually have to, what times is to the negative 12 and adds to negative 1? 1 and 12, 2 and 6, 3 and 4. Oh, negative 4, positive 3. So x plus 3, x minus 4. That's factored. It's still all equal to 0. So now each individual factor, the x plus 3 equals 0, gives us x equals a negative 3, and x minus 4 equals 0, and that gives us x equals 4. And we get the two answers right there for number 30. All right, next one, number 31. Oh, this is an x cubed. That means we should get like 3 answers on this one. First, let's get it equal to 0. Subtract 24x on both sides, and we get 6x cubed minus 24x equals 0. Factor, can we pull out a greatest common factor? Yeah, there's a 6x. We're left with x squared minus 4. This one can factor down further. It is a difference of squares, two terms, and it's a subtract sign between two perfect squares. So this really is 6x. This is x minus 2, x plus 2. That's the pattern for a difference of squares, just like we did up here in number 28. Notice now we have three factors that we can set equal to 0. We get 6x equals 0. Yeah, this one gives us an answer. Divide both sides by 6 and we get x equals 0. Here we have x minus 2 equals 0. That'll give us x equals a positive 2, and this one will give us x equals a negative 2. And those right there are three answers. Notice we were at a third degree polynomial. We get three answers out of that. All right, number 32. We got to get it equal to 0. So add 12x to both sides. X cubed plus 7x squared plus 12x. Notice we got to plus these 12x plus 12x to both sides equals the 0. Greatest common factor. There's an x everywhere. So we're at x squared plus 7x plus 12 equals 0. And this one is now a 1, 2, 3 trinomial, leading coefficient 1. So that means it's going to break up very nicely in one step. 12. What times is to 12 and adds to 7? 1 and 12, 2 and 6, 3 and 4. There's our adding to 7 right there. So it's an x and a plus 3 and a plus 4. And there's your x right there. Now we set each equal to 0. We get x equals 0. X plus 3 equals 0. We'd subtract 3 and we get x equals a negative 3. X plus 4 equals 0. X has to equal a negative 4. Excellent. And now number 33. Get it equal to 0. It is. Check. Good. Now factored. Is there a greatest common factor here? It looks like 4x. We get 6x squared minus 11x plus 4. 6 times 4. Oh, 3 terms. Leading coefficient is not 1, so we have to use the AC method. 6 times 4 is a 24. Let's write that out here. That could be a 1 and a 24, a 2 and a 12, a 3 and an 8, a 4 and a 6. And what adds to a negative 11? That's a negative 3 and a negative 8. Those are the ones that will add to the negative 24 there. So we get 6x squared minus 3x minus 8x minus plus a 4. We now have 1, 2, 3, 4 terms. Chainsaw. Take out a 3x. And we're left with 2x minus 1. Then here we can take out a minus between an 8 and a 4, and hopefully we're left with that exact same thing. Take out a 4 and we're left with 8 divided by 4 is 2x. 4 divided by 4 is 1, but it's got to be a minus 1. Good, because 4 divided by negative 4 is a minus 1. All right, so that leaves us with that 2x minus 1 times the 3x minus 4. And then this 4x just kind of sits out here in the front while we were taking care of that other trinomial. And that all equals 0. So we get 4x equals 0. Divide by 4 and we get x equals 0. Now this next factor would be 2x minus 1 equals 0. So we would add 1 and then divide by 2. And we get x equals 1/2. And then the last one, 3x minus 4 equals 0. Solve this little equation by adding 4 and dividing by 3. So we now have those three, there we go, those three answers for number 33. And it was a third degree polynomial, telling us we would have gotten 3 answers. Excellent.